All right, so what you're going to be learning today is how to find arc measures within a circle. There are two types of angles. So there are central angles, and that is where the vertex is in the center. Just a reminder, this is the vertex of your angle. Okay, so here is a central angle. And then we're also going to learn about inscribed angles, and that is where the vertex is on the outside of the circle. So here you can see that the vertex is lying on the outer rim of the circle. So examples of central angles, anything that looks something like this, that's a central angle. Anything that looks like this, that's a central angle as well. Okay, so anything where the vertex is on the center of the angle is called a central angle. On the other side, we have inscribed angles, and examples of those is just having a point that's not going through the center, okay? So anything that's on the outside of the circle here is going to be an inscribed angle. So that is an inscribed angle. Let's see, another example of an inscribed angle could have anything that looks like this. I had someone notice before that with inscribed angles, they touch the outside of the circle 3 times. So that's one way that you could look at that. Just ask yourself, does it touch the outside of the circle 3 times? If yes, then it's an inscribed angle. And then, of course, the central angle, again, you're just going through the center of the circle. So this is a central angle here. Okay, we're going to go over some problems now. So we're going to look at some properties of central angles and properties of inscribed angles. So let's move on down. Okay, with central angles, it's actually quite simple. So a central angle is going to equal the measure of its arc, okay? And I haven't really told you what an arc yet, but it really is just this on your circle. So if I said arc AC, I'd be talking about this measure here, okay? So again, the cool thing about a central angle and its arc is that they are the same measure. So if I look here, ABC is opening up to this arc AC. Okay, so this angle is creating this arc AC. If the measure of ABC, so it's saying if this is 178 degrees, what is the measure of arc AC? So, as I've already told you, the measure of a central angle and its arc are going to be the same. So, if ABC is 178, what is the measure of arc AC? Which we write like this. Well, the measure of arc AC is just 178 degrees. And that's it with that problem. Okay, if we're going in the reverse, so if arc AC, so if this arc equals 168 degrees, what is the measure of angle ABC? Well, same thing. So if the arc is 168, then the central angle is 168. So this is 168 degrees. So if you see a central angle, it's pretty easy. Another thing that I need to tell you about is that this is a minor arc, which is what we're going to be working with a lot of the times. But you can also have something called a major arc. So a major arc is always going to have 3 letters in it. So if I had like this as point D, then I could call this major arc ADC. So ADC would be a major arc. And if I wanted to find the measure of major arc ADC, let's say using this example here, a circle measures up to 360 degrees. So if this is 168, we would simply subtract from 360 to figure out the measure of major arc ADC. So if I did 360 minus 168, let me figure that out real quick. 360 minus 168. Then major arc ADC would be 192. So this was just a side example using example 2. Okay. Again, you won't really be working with this as much, but it can be helpful. Okay, so The moral of the story here is that if you have a central angle, it's equal to its arc. So over here, central angles are equal to the measure of their arc. Pretty nice and easy. All right, now we're going to move on to inscribed angles. Okay, inscribed angles. They're a little bit more complicated, but they're really not bad. So inscribed angles, moving on here. Again, an inscribed angle is something that touches the circle 3 times. So here it's touching the outside 3 times. So this is an inscribed angle here. If the measure of PQR is 70 degrees, what is the measure of angle PR? Okay, so these are actually a little bit different than the central angles. They're not quite as easy, but like I said, they're not that bad. The relationship here is that the angle, so this angle opens up to this arc. Okay, so it's creating that arc. If the angle is 70 degrees, then the arc is 140 degrees. So that is just going to be double. Okay, so if PQR is 70 degrees, then PR is 140 degrees. Which again, we just got from 70 times 2. Okay, now going in the reverse. If the arc is double the angle, then now we're going to do the angle is half of the arc. So if instead I'm given that PR, arc PR, measures 160 degrees, then the measure of the angle that corresponds to that arc is going to be half. So if PQR is 160 degrees, or sorry, if PR is 160 degrees, then that means that the measure of the angle is going to be half, which would be 80 degrees. Okay, and again, we got that from 160 divided by 2. So properties of inscribed angles is that they are half of their arc, or you could say that the arc is double the angle. So again, moral of the story, inscribed angles are half of their arc. You could also go in the reverse and say that the arcs are double of the angles. I'm going to show you really quick how this assignment is going to work in Delta Math. So I'm going to go ahead and switch screens. Okay, this is what your assignment looks like. In circle M with LPN measuring 34 degrees, find the measure of the arc. Okay, so find the measure of arc LN. So if this is 34 degrees, we said that if it's an inscribed angle, which it is, then the arc is going to be double the angle. So we would do 34 times 2, which would give you 68. So we just simply write in 68, and it already has a degree symbol there for us, so we don't have to worry about that. Okay. And so this is how you're going to do this, and it does give you an explanation. If you get lost, you could also view some examples. But again, the arc is double the angle. So this one was given the angle, find the arc. Okay, let's look at another problem. All right, this one is saying, given EG, arc EG is 78, find the measure of the angle. So the angle is going to be half of the arc. So we'd say 78 divided by 2, which is going to be 39. Okay. And let's find a problem with a central angle in it. If it will load. Okay, this is still an inscribed angle. So given the angle, the arc would be double. So this would be 120. All right. I know there's a central angle hiding in here. But the central angles are very easy. So if you are given a central angle, it literally just equals the arc. So let me go back and see if I can find one. Okay, that's still an inscribed. Still an inscribed. Still an inscribed angle. Here we go. Okay, so if you're given an angle that doesn't go through 3 points on the outside, but instead the vertex is on the inside, then it's literally just going to equal the measure of your arc. So if I know ln is 74, that means that lmn is 74. Okay, cool. So I don't think this assignment is too terrible. Either it's going to equal the measure or it's going to double or half. So you just really have to figure out what is the problem asking me and hopefully look over this video once or twice and get the idea. All right, hope you guys enjoyed this video and I will be talking to you soon, virtually, I guess. Stay safe, wash your hands, and enjoy your time at home. Bye.